everyone, welcome once again to another episode of Let's Get Soroban. For today's episode, we're talking about the contract storage and read and write operations in Soroban. Before anything else, I would love to explain to you guys what storage is all about and also some other kind of important concepts. There's a concept called TTL. What is TTL? TTL is an entry time to leave. It is defined on how many ledgers we made until the entry is no longer alive. Talking about ledger, what is ledger? Ledger is more of like a block in the blockchain. So it's more of like it's defining the time for this block to be alive. TTL is made up of the minimum and the maximum TTL. So talking about the storage kinds in Soroban, or like EVM chain, whereby we have like the memory, you have when you're using a struct though, we have the memory, we have the storage. So using the memory means you're just going to get the little memory from it, because that's the memory of that, which is kind of temporary, and using using the storage means you're trying to access the storage, like the main storage of that block. So in Soroban we have the instant storage, the temporary storage, and the persistent storage. What's the instant storage? Instant storage has like the temporary storage. Talking about the temporary storage, to access it you use env.storage.temporary. If you're accessing the instant storage, you use env.storage.instance. If you're accessing the persistent storage, you use env.storage.persistence. For the temporary storage has very cheaper gas fee. It lasts only for the duration of a single transaction, and not only that, the temporary storage is permanently deleted when the TTL goes to 0. It can never be restored. For the instant storage, it persists for the lifetime of the contract instance, and it has limited amount of storage available. For the persistent storage, it's used for long-term data storage and it lasts indefinitely, even across contracts. So whenever you want to write your contract, you want to access the data, you want to access the data, or you want to write a data to the blockchain, you have to be very careful the kind of storage you're using, because you're either using the instant storage, or you're using the persistent storage, or you're using the temporary storage. Moving on to us trying to study a contract. This is actually an increment contract, where you increment a number and decrement a number. But right now we have just only one function, a public function called increment. But before anything else, like I explained for the last time we had for the last episode, I said that one line they would have to, the first line when I see your contract is this no std, which means that this is an attribute. So I'm using this here, you'll be able to import the necessary functions you need in the Soroban SDK. The next line of here is the counter. The counter, it can be named anything. It can be named number or anything you want to do. But this using the symbol short. Symbol short is more of like a 32 character string. It has a 32 character string maximum. So anything more than that, it won't really take that. So we use this to get the key of the counter from the blockchain, from the ledger. So on doing that, the next line of code, like I explained before, is the contract attribute. This contract is a Soroban contract, and you have to implement a Soroban contract. And with doing that, you're able to implement the increment contract struct. So what you have to note, like I explained before, is the fact that when you are implementing your contract, it should have the same name with what you use in declaring the struct in the first place. Moving on, while implementing the contract, we have to create the functions, right? There are different functions that have to be in the implementing contract. That's why we have this increment contract function, and this contract returns an e32 integer. One thing you have to know is that whenever you're trying to access the blockchain in Soroban, using Soroban, you have to include this env in here. So when you're doing that, the next thing that was done here, looking carefully and studying this, you will see that you have the env.storage.instance. Why is it that instance storage type being used instead of using the temporary storage type or using the persistent storage type? It's because of the fact that, like I explained, the instant storage type, it persists for the lifetime of the contract, right? And has limited amount of storage available. And the funny thing is that the most important thing to note is the fact that instant storage has lesser gas than persistent storage. Temporary storage wasn't used because temporary storage, it's more of like just you are getting a memory of that, and we don't need that memory. We don't need to get a memory. We are getting the instance because we want to get that data and be able to write into the blockchain. That's the reason why the instant storage type was used. And while doing that, the key is being used to access, which is this counter key, and then a default value of 0 is being set if no value was gotten from it. And on doing that, the next thing that was done was the count was incremented, and same way to set the count, the instant storage type was used to set the count, and using a reference to the key and also a reference to the new count variable we have. And there's something that is very important and you need to note is the extend TTL. TTL, like I explained earlier, is the time to live, and it's more of like how many ledgers is remain until the entry. So we need to extend the TTL of like, okay, this is the amount of time we need this contract to be alive, kind of thing. But this is not really a must. Not everybody do that, but it's actually necessary and it's very important to do that as well. On extending the TTL, it's important for you to know that this first time has to either it's equal to this or it is lesser than it. If it is more than it, imagine that this ends up being 200, there's going to be an error. There's going to be an error in the contract and it won't set. It's going to be no process will work. But when you set this less than it, if it's 80 or 90 or whatever it is you want to set, that will make it successfully work. So you can see that after all this was done, the count was returned because I have to return an E32 integer, so unsigned integer as well. So after all this, the important thing you will need to do, of course, is to build a contract using Stellar contract build. And when the contract is done building, you deploy your contract and you have your contract on Soroban testnet. And like I explained the last time, when the contract has been built, you will see the WASM code in here. Depending on what you name your contract, the WASM code will be in here, and then you can use that to deploy your contract by using this command to deploy the contract, making sure that the WASM code name is the same and the source name is the same and the network is the same. On deploying that, you have your contract successfully deployed in Soroban testnet, in Stellar testnet. So thank you so much for your time. See you next time.